All right. Hello, everybody. Hope everybody's doing well. Today, instead of going for answers or what x equals, we're going to go backwards. We're going to work with what x equals and build a polynomial. The notes say building equations. That would be a typo that I was too lazy to correct. So we're going to remind ourselves how we solve these problems. So we're going to practice factoring. We want something that will add to 6, but it will times to 5. Okay, so we need to think of things that times to 5, and there's only 2, 5 and 1. And fortunately for us, they add up to 6. Okay, we've got a 0 on the right side, and that's important. Okay, so 5 and the 1, they're adding to 6, they're timesing to 5, and the 0 part means that one of these parentheses equals 0, because you've got two things timesing together. So either the whole first one or the whole second one equals 0. So if we want to figure out, well, what is x? What could make that equal 0? It's the opposite of whatever it's adding to. So if there's a 5 in there, that makes x a negative 5. Now there's a second option for an answer, and that comes from the other parenthesis. We do the same thing. Whatever's in there, we're going to pull out the opposite, and that's the answer. So we now know what x equals. It equals negative 5 and negative 1. In a minute, we're going to start a problem where we're going to do the exact opposite. They're going to give us these roots, or these answers. Sometimes they're also called zeros, and we're going to go backwards. But first, we're going to go over some basics of multiplying, because there's a couple of things that I've seen people do that might trip you up. So first of all, basic multiplying. 3 times 7 times 2. The 3 does not distribute to the 7 and the 2. You just hit the first two numbers, and the 2 will wait for them to be finished. So 3 times 7 usually gets you a 21, and then we're going to times it by 2. And now that can multiply, and we get a final answer, 42. Now, how is this problem on the right different? It's not. It's still 3 times 7 times 2. So the idea that 3 would distribute, it doesn't. It only hits the next parenthesis. So 3 will hit 7 again, and we will still get 21. And just to keep it looking the same, we'll go ahead and put it in parentheses. And then once those parentheses are combined into a new parenthesis, now you can hit the next guy. You can hit the 2. So again, we get the 42. So there's no difference between those, and you're not jumping around hitting multiple parentheses at once. A single parenthesis can hit a single parenthesis. That's going to be important, because I've seen a couple of people doing something different in the past. All right, so we're going to look back at these parentheses. So we had a positive 5 turned into an answer of negative 5. We're going to go backwards, okay? Because what we've been given is that x equals these three numbers, 5, 2, negative 4. We're going to build the polynomial that made these. These are the zeros or the answers. It's also going to tell us in the instructions on your worksheet, it's going to talk about something called least degree. What that means is there's no other random answers that we have to worry about, nothing else that equals x. The other thing it's going to talk about in the worksheet is it's going to say that it has a leading coefficient of 1, and what that means is the x's in front just have a hidden 1. There's no other numbers that have been factored out and that are wandering around. So we're going to work with bare bones basics. And we're going to take these zeros and work them backwards until we have the polynomial that created them. So to go backwards, the first thing we're going to do is we're going to recreate the parentheses. There are 3 answers, and there's a parenthesis for each one. Okay? There's a positive 5. When it goes in, it will go back into its opposite form of a negative 5, because that's really the x's 5 that's canceling a negative 5. Same thing with the 2. The x's 2 gets canceled by the negative 2, and on the last parenthesis, again, opposite sign goes into the parenthesis, negative 4 becomes positive 4. So boom, we've got our parentheses. We've got 1, 2, 3 parentheses, and just like we did with the 3, 7, and the 2, we're just going to hit the first 2 parentheses against each other in the beginning. X plus 4 is just going to wait. These aren't conjugates, so we're going to FOIL them. Okay? X will hit both terms in the second parenthesis, and so will the negative 5. And we're going to get all of these together. And the x plus 4 is just waiting for us. And because there's still more multiplying to do, the answer to the first 2 parentheses is also in a parenthesis. Now there are some common like terms that we can combine to make this math a little bit easier. So the negative 2x and the negative 5x, those are now combined. And we've simplified that first parenthesis as much as we can. So now we're going to go ahead and take the first parenthesis, the new first one, and times it against the last parenthesis. Each term in the first will multiply by each term in the last. So they kind of take turns distributing, if you want to think of it that way. So the x squared will hit the x and become x cubed. X squared hits the 4, and that will become a plus 4x squared. So that first term is now distributed. Second term's turn, and I'm going to put him underneath, mainly because that's how I organize them if they aren't just a couple of binomials. Last guy, here comes the 10. He gets the bottom row because he's the last term we're using. Okay, and all this collection, we need to find any like terms. X cubed doesn't have any, so it's just that. There are a couple of x squareds, though, so we'll combine those. And there's a couple of linear x's. Linear has a degree of 1, so we'll combine those. And we're just adding and subtracting at this point. The constant, nobody else has a constant, so it's just plus 40, and we're done. This is the polynomial that made the answers we were given in the beginning. We've gone backwards. All right, let's try a slightly stranger one. Okay, this time there are 4 answers. But the first one is a little weird. In fact, the 0. Anytime, it doesn't even have to be the first answer. It's just the 0 is kind of strange. Because 0 isn't positive or a negative. I'm going to go ahead and call it minus 0, but x take away nothing is still x. Add nothing is still x. So 0 is just the x. And then we're going to go ahead and fill in the other answers behind it. And remember that you're doing opposites. So negative 2 is plus 2. Negative 1 will become plus 1. So all of these are opposites. And again, only a single parenthesis can hit another parenthesis at any given time. So we're going to hit these first 2 parentheses together. X will distribute. This one's a little bit easier than foiling because it's just straight up distribution. So x and x is x squared minus 3x. There is more multiplying to come, so I'm going to keep that in parentheses, a new parenthesis. Now, while I'm at it, I'm going to go ahead and let the back 2 multiply since they weren't doing anything else. If they'd been doing anything else, I couldn't do this. But since they were just sitting there, I can go ahead and multiply them. So I'm foiling rather quickly here. We do have some like terms in the middle that we can combine. So that'll give us an x squared plus 3x plus 2. All right, so we have a new back parenthesis, the back 2 combined and the front 2 combined. We're going to bring down the new front, and now we're going to take the front term and distribute it. And then negative 3x, and he is a negative 3x, so don't lose your negative. He will also distribute. So here comes the x squared. He's distributing to each term now, so we have x to the 4th. Plus 3x cubed. So watch how many x's you're collecting as you go. Plus 2x squared. Okay, 3x's term, and he is negative. So we have a negative 3x cubed. Again, watch how many x's you're collecting with your exponents. Okay, minus 9x squared minus 6x. And we've got everybody together. Time for like terms. We have a pair of x cubes that are exact opposites. They're additive inverses. They cancel. So those guys are gone. The x squareds do not cancel, so we'll just combine them. We have a minus 6x at the very end, who doesn't have any like term buddies, and that's it. That is the polynomial that gave us the original 4 answers. The second version doesn't have a constant, and the reason it doesn't have a constant at the end is because one of our possible answers is a 0, and it basically times through and killed off all the constants, so that's why there's no constant at the end. All right, it is time to get crazy. We're going to work with zeros that are irrational. That means they're not integers. They are decimals that don't end, and usually they come in the form of square roots. So we have a bunch of square roots. Now, if you'll notice, you might see a pattern here. We have a front number that's positive, and then basically the same number, but it went negative. It's almost like they've mysteriously come in pairs. So x equals these funny irrational things, but let me show you another way of writing them. You could also say that x equals the plus and the minus version of each 2 copies. Okay, so this is when you get those funny answers that are plus, minus, and a radical, and you really can't do anything more than that. That's basically what's happening. So they do come in pairs. In fact, they have to. So there's the pairs, and they're actually conjugates in disguise. We'll see a more recognizable conjugate in a second. But first of all, let's get these guys in. We get them in the same way we get the integers in. They come in as opposite signs. So if they're negative, they'll become positive, like this guy. And then bringing this 2 radical 3 in, he's going to go negative because he was originally positive. And they come in as a single term. Don't separate the 2 and the radical 3. Bring them in as a single term, and what will happen is that sign front will change. All right, and what we have here are a pair of conjugates. Notice that the middle sign is different, but everything else is the same. And what that means is we can do the fun conjugate shortcut. We don't have to FOIL the whole thing out. We only have to hit the first and the last terms, because all the middle terms, if we were to FOIL it out, all the middle terms would end up canceling. So we've got this beautiful shortcut. So we have x on x, that's x squared, and then a radical 7 times a radical 7. One of them is negative, so don't lose your negative, but that's going to be just a normal 7. Okay, it's basically radical 7 squared, or another way of thinking about it is if you have radical 7 times radical 7, that's radical 49, and his square root is 7. You can also think about it that way. So there's a couple ways to internalize that. All right, next group. These are a little bit more complicated, but really not that bad. The x is still going to become x squared. It's the other things that are a little weird. Still negative. Negative times positive is negative. What we're going to do is we're going to take the normal thing, the 2, and times it together to get a 4. So that's the 2 times the 2. And then we're going to take the radical 3 times the radical 3, which would be a radical 9 or just a 3. And since that's a term, it's a collection of multipliers. They're multiplying with each other. So the 2 becomes the 4, and then the radical 3 becomes just a normal 3, kind of like the 7 did. So altogether it becomes a 12. And now we have 2 parentheses. We've taken our 4, we've times the first 2 and the last 2, and we are ready to basically finish out the problem. Now these are not conjugates. They don't have the same numbers, they're the same sign in the middle, so we are going to have to FOIL them. We can't do that funny first-last trick. So this needs a complete FOIL. So x squared times x squared, we get x to the 4th, and then we're going to get x or 12, x squared, and that one's negative, minus 7x squared, and finally negative 7, negative 12, that's a positive 84. We're basically at the end now. We just need to combine some like terms in the middle, and that will be it. So even though these look a little scary and a little funny, in my opinion, they're actually easier than some of the integers just because they have that conjugate trick in the middle going for them. So really not that bad. All right, So let's look over and find a more recognizable conjugate. We have radical 2, negative radical 2. That's a lot like the 7s. So again, they come in a pair, but here's the real conjugate that's more recognizable. And this is when you get that 4 plus or minus radical 5 is what's going on here. And you can't combine them. So you have the positive version and the minus version. So again, these things are always coming in pairs. There's always another half to it, a plus and a minus version. So let's throw them into their parentheses. Again, opposite signs, and that's pretty easy for the first two. Now, the easily recognized conjugates, they're a little stranger, but they're still going to come in as an opposite. The problem is there are two terms coming in as opposites. So the 4 goes negative, and so does the radical 5. And for the second one, that 4 is a positive, so he comes in as a negative. And the radical 5 is a negative, so it comes in as a positive. So everybody coming into the parenthesis is doing this opposite thing. And that includes the separated conjugates where you have the integer and the irrational number, the radical number. All right. Conjugates just like the last one, so x squared. And then radical 2 is a normal 2. There is a negative involved, so still negative. Now comes the weird part. These guys actually are conjugates like the first two parentheses, but you have to use a little bit of imagination to see it. What I'm going to do is I'm going to group the first part of the parenthesis, x minus 4, and it repeats in both parentheses. So I'm going to call it thing. So x minus 4 is now thing. And then minus radical 5, and then here's another thing, a very technical math term, plus radical 5. And if you look at it this way, it's a lot easier to see that, well, this is actually a conjugate. So we should be able to times the first terms and the last terms, just like we did on the other one. So I'm going to kind of wall this off just because I'm going to play around with this until I'm ready to involve the other guy. So thing times thing, but we have to remember that thing and thing are a little bit more complicated than just things squared. Each thing is an x minus 4, so I'm going to go ahead and times thing by thing. So x minus 4 times the other x minus 4. Okay, that involves a full FOIL. There's not going to be any canceling in the middle, so I can't skip all the inside-outside parts. There are shortcuts to x minus 4 squared, which is what this basically is. If you want to look them up, I can show them. We just haven't talked about them in class. But if you're familiar with those shortcuts, feel free to use them. All right, so there's thing times thing. Now we're going to do back times back, and it just adds on to the middle, or adds on to the last part of it. So negative and then normal 5, radical hitting radical. So we're going to get all the like terms together, and there it is. Okay, so we've simplified the more complicated thing times thing, and then we're going to bring down the very first that was waiting for us. There it is. And now we're kind of back to where the integers were. We're going to FOIL out these very last parentheses. Okay, remember that each term from the front gets a chance to distribute. So it's basically distributing on steroids. All right, here we go. So we've got an x to the 4th minus 8x cubed plus 11x squared. And then we're going to take that negative 2 through. Don't forget the negative. Okay, the negative is kind of important. It belongs to the 2. And now we're looking for like terms. Highest exponent is the 4th, and he doesn't have anybody who's friends, and neither does the cubed guy. No friends there either. No one to join with. Sometimes it's sad being a number letter. The squareds have some friends. The quadratic terms have friends. Linear, no love there. And minus 22. And there should be a squared on that 9x, but yeah, pretend there's a squared on the 9x. My bad. All right, last but certainly not least, we are going to play with the imaginary zeros. This is where you have negatives hiding under the radicals. Speaking of radicals, we're going to look back up here and notice that these radicals are always coming in pairs. There's a positive and a negative version. That is true for the i's because the i's are really radicals. That's a radical -1. So the catch here is that they didn't give us all the zeros. What we need to do is we need to fill in the other zeros that are missing. We're going to fill in our conjugates because they're really complex conjugates with a real number of 0. So there's a 2i, but there's also a -2i. There's a -3i, but there is also a +3i. These things always come in pairs because radicals, the creation of a radical, if it's an even root, is a plus and a minus. All right, we're going to bring these in just like we've done everything else. They come in as their opposites, and because radicals are involved, you just can't see them, they're going to make conjugates for them, which makes our job a lot easier, actually. So here come the 3's. Again, when you put them in the parentheses, they're coming in as opposites, because what's happening is you're seeing what x equals, and x is canceling the other number. All right, we have a pair of conjugates, which means first times first, last times last. It's a wonderful little shortcut, saves all the canceling, pencil lead, ink, paper, all that stuff. So we have x squared, and then we get 2 times 2 is the 4, it's negative, and the I times I becomes an I squared. Now some of you are going to jump straight to the +4. If you're confident doing that and you feel good about it, go ahead. A lot of you are getting quite good at that. If not, go ahead and multiply everything out. Just remember that I times I is I squared. And that I squared is the number -1. That's the sign changer. Okay, so it's going to make that a +4. -4 times -1. We're going to change the sign on that. So you can jump straight to that -2i times +2i gets you a 4. Some of you are already doing that. If not, doing the whole thing doesn't hurt either. And with the conjugates, we now have 2 little binomials that we can FOIL because these are no longer conjugates, so we're going to have to do a full FOIL. So the x squared and the x squared, there's our x to the 4th. And I am just messing up on the exponents all over the place, but I am a little too tired to fix it. So we're going to pretend that first x is an x to the 4th. The middle x should be an x squared. And the back is a +36. Because I did this with very little sleep, and now I'm doing the audio, and I'm picking up all the mistakes. So just pretend that's an x to the 4th and a 13x squared. All right, once again, we're going to fill in the conjugates. So we've got an I, but we need the other one. We need the -I. Now here we have the full complex number with the -6 in front. The only part that is doing that plus minus is what's right in front of the radical term. Okay, so the normal number part, the real number, the -6, doesn't change. If it was a +6, it still wouldn't change. That normal number will be the same. It's the middle term between them, the middle term in front of the I part of it. Okay, so the imaginary part. The imaginary part changes sign. The real part does not. All right, we now have the conjugates. We're ready to toss them into a pair of parentheses. Again, they come in as opposites. I did at least get that part right. And then here comes the weird part. Just like up above, the whole thing coming in has to go opposite so the x can cancel each part of it. So -6 becomes +6 in both parentheses. And then that I also ends up changing sign as it goes into the parentheses. The first two groups are fairly straightforward. They are conjugates. We can do the conjugate shortcut. So we're going to end up with an x squared and then negative I squared if you're not jumping immediately to the solution. In the other parentheses, if you look at the first two terms as a unit and the extremely technical math term of thing, we have thing minus 2i and thing plus 2i. That's a conjugate. So we want thing times thing and last times last. Thing times thing is x plus 6. And again, I'm just going to kind of wall this off so that I don't get it confused with the front part while I'm messing around with it. So x plus 6 times x plus 6, that's thing and thing. And then we have negative 2i times positive 2i minus 4i squared. Okay, while I'm here, I'm going to go ahead and simplify that earlier starting parenthesis. So we should have x squared plus 1. So negative I squared, negative 1, negative 1 plus 1. Okay, in the back, I'm going to go ahead and FOIL because x plus 6 times itself is not a conjugate. You need opposite signs for a conjugate. Okay, so there's the x plus 6. And then we have minus 4i squared. But because it is a 4i squared, we're going to shift that into a plus 4i. And you're here in just a second. Because the I squared is a negative 1. You're squaring a radical. The radical is going to go away. Okay, x squared plus 1 is still waiting for us to finish up in the back. In the back, we're going to combine all the like terms. So we've got that 12x in the middle, a 40 in the back. Notice that back term, negative 2i, positive 2i, it just adds into the thing multiplying. It doesn't times in. Okay, we're on to the last part. This is where we distribute everybody from the front. And we end up with an x to the fourth plus 12x cubed plus 40x squared. And then the next part's easy. We're going to times it by a 1, so we basically just copy it down. Because multiplication with 1, always nice. I am going to throw a 1 in front of my x squared because it's got a like term, and sometimes toward the end of these problems, it's really easy to forget that, oh, you do have a 1 there that you have to add in. All right, so we're again on the hunt for like terms. We're watching our exponents for like terms. There's only one set of like terms. Those are the squares. And I got this one correct. I think at this point it was lunchtime, so I may have been waking up a little at the thought of food. All right, we have an answer, and we are good to go. Okay, so that's life with the imaginary in the glare. There it is. Life with the imaginary zeros. Not as bad as some people think. So good luck and let me know if you need any help.